All right, so we're going to be working with the properties of equality. We're going to work with the addition, subtraction, division, and multiplication properties of equality. We're going to combine 2.1 and 2.2 into this one video. These are just simple one-step equations, and then we'll also do a few in these two sections that involve simplifying first. The way I like to look at this stuff is I'm just trying to undo everything that's happening to x, and I'm going to undo it in the reverse order of PEMDAS. For now, we only have one step, so we're just going to undo what's happening. So in the first one here, I'm adding 4 to x. So to undo my addition of 4, I'm just going to subtract 4. And I'll subtract 4 from, if I subtract 4 from one side, I have to subtract 4 from the other side because I have to keep these equations in balance. So now on the left-hand side, I have x plus 4 minus 4. So the plus 4 minus 4, that's just going to become 0. So I just basically have x by itself on the left, and then 10 minus 4 is 6. And so x is equal to 6. And you can check that by taking 6 here and plugging it back into the original equation. Always plug it back into the original. I got 6 plus 4, that's 10, and that equals 10. So the next one, this one, we could rewrite this one as an addition statement. I wrote this one specifically so that we can see that all I want to do is just undo the operation that's occurring. So here I'm subtracting negative 6. So to undo that, I would just add negative 6 to both sides. Add negative 6. It's easy. This is an easy way to looking at the operation and just saying, okay, I need to undo subtraction, so I'm going to add. And I'm subtracting negative 6, so I'm going to add negative 6. It's a really easy way to figure out what it is I need to add or subtract from both sides. So I now have just x on the left, and then on the right, 20 plus negative 6 is positive 14, and that is our answer. On this one here, x divided by 4 equals negative 20. I'm dividing by 4, so to undo that, I will divide by 4, and you can put 4 over 1 if you want to. So this will cancel, and this will cancel, become 1 and 1. So now I'm just left with x, or 1x on the left. And if I multiply the left-hand side by 4, I have to multiply the right-hand side by 4. So this is now negative 20 times 4, that's negative 80. And this last one, I'm multiplying x by negative 5. To undo that, I will divide by negative 5. Divide the left side by negative 5. I have to divide the right side by negative 5 to keep it in balance. That is a horrible looking 5. So I will rewrite that. And I got x equals negative 5. Okay, so these are two examples where you have to do a little bit of simplification before you can start to solve. So you're always wanting to simplify first, simplify both sides. So my left side, I have a bunch of work to do here in terms of simplification before I do anything else. The right side on this one, this is negative 41. It's as simple as it can be written. So the right side is simplified. So here I've got a variable term, constant, and a constant. I need to combine my constants and combine my variable terms. So I'm going to rewrite this as an addition statement. And then once I do that, then I can move stuff around freely using the commutative property. So now I have negative 8n plus 9n plus negative 17 plus negative 4 is equal to negative 41. And now I can combine my like terms. So negative 8n plus 9n, that's just 1n or n. And then plus, and negative 17 plus negative 4 is negative 21. And that'll equal negative 41. And now I've got the left side as simple as it can be and the right side as simple as it can be. And now I can actually start to solve. So I'm adding negative 21. So to undo that, I'm going to subtract negative 21. So I will do subtract negative 21, and I'll subtract that from the left and from the right. And so what I end up getting on the right is negative 41 plus 21, and that's negative 20, so I get n equals negative 20, and okay, and so I can take this negative 20 here, and I can plug it into the original equation and check my work, and that's a great way to find out if you actually got this correct. So let's move on to the next one. So I first need to distribute this negative 12 in here, so I've got negative 12d, and then minus, and then it'd be negative 12 times 5, that's negative 60, minus 29, and that equals 43. I can rewrite this here as, if I add the opposite, I change this to addition, I change this to its opposite, so that'd be plus positive 60. So we'll rewrite that, and we'll get negative 12d plus 60, and then I'm going to write the plus negative 29 there, equals 43. So all I did was just add the opposite, so change it to an addition problem. I have negative 12d, so I still have some more simplifying to do, because I've got a variable term here, but I got two constants. I need to add those up. So we will have negative 12d plus, and then this is 31 equals 43. So now we have everything as simple as possible. We can start to solve. So we're going to undo everything that's happening to d in the reverse order of PEMDAS. So this is a two-step problem here. And I've got to start by undoing, like I said, everything in the reverse order of PEMDAS. So I'm going to start by undoing addition, subtraction. So I'll start with this. So I'll subtract 31 from both sides. Now I have negative 12d equals, and then 43 minus 31 is 12. Now I can undo I'm multiplying d by negative 12, so I'll undo that by dividing by negative 12. And I get, I'm going to move this up just a little bit, I get d is equal to negative 1. And so there is our solution there. Bring in your questions, make sure you ask them if you have any, and we'll talk more about this stuff in class.